Hare Krishna. Hope you are doing well. Great. Let's get started with this question on probability computation, and there's going to be a fair element of set theory involved as well. So you have a fair die which is thrown three times. Essentially, it means the outcomes 1, 2, 3, 4, 5, 6 for each die. Throw 1, throw 2, throw 3. They are equally likely, and we have to compute the probability that 4 is the maximum value that appears among these throws. So there's an element of converting this English language to mathematical language and then checking what is exactly this probability. Okay, let's get started. So it's saying 4 is the maximum value, which means in each of the three die throws, it shouldn't exceed 4. It should be less than equal to 4. So the probability is this. The variables are independent. Here x1, xi denotes the outcome on the ith throw. So it's independent. So 4 by 6 times 4 by 6 times 4 by 6, which is 2 by 3 whole cube, which is 8 to the power 27. And that's absolutely the incorrect answer. The reason is, look at it very closely. The question is asking 4 is the maximum value that appears. While this is ensuring that no value crosses 4, it is not guaranteeing that 4 is the observed maximum value, because it could very well be that x1 is 3, x2 is 2, and x3 is 1. Over here, this thing also falls under this set only, but this doesn't satisfy what the question is asking. So the actual version over here in terms of set theory is this. Agreed. This is a part of the actual computation. So this part is there. This ensures that the maximum value is not more than 4, but it is this part that ensures that at least 4 is observed also. So it's the intersection of these two. Looks complicated, right? So this is where our motivation should be to simplify it. Probabilities of independent random variables are always very beautiful when everything is in intersection. So if somehow we can convert this union thing into intersection and then deal with it, it would be great, right? And the way to do that is to just transform the problem into a more manageable one. We know this thing, and this probability is essentially this event intersected with something, and we know this very simple set theory based probability lemma. So this can be our event A. This is A intersection B. By the knowledge of De Morgan's law, it should be intuitive that the complement of this thing will become this intersection, this. So this would be easy to deal with, right? And that should be our motivation to transform this setup into, this setup into this. So here we are interested in A intersection B, and this is our PA, this is our PA intersection B complement. So just the difference of them. And once we write it like this, we can, this part is very easy. And this part also, if you think about it very logically, everything is less than equal to 4 and nothing can be 4. It means it's equivalent to everything being less than equal to 3. This becomes a simple exercise in computation, and you have this answer. Again, the two things was writing the English language properly in mathematical language, because this may have seemed like the right answer, but you have to be more mindful that whether it's actually satisfying what the question is stating or not. And the other thing was, you don't have to compute the probability directly if it looks complicated. You can use some tweaks of basic set theory to transform the probability in a more manageable form as well. That was it. Take care. Hare Krishna.